The A320 flight controls operate with a fly-by-wire FBW concept. This FBW concept reduces crew workload and enhances safety. The A320 side stick or autopilot electrical outputs are sent to 7 Electronic Flight Control System EFCS computers that send electrical signals to electrically controlled hydraulic actuators. There are 2 elevator aileron computers, ELAC, that provide elevator trimmable horizontal stabilizer THS control and aileron control. There are 3 spoiler elevator computers, SEC, that provide spoiler control, and 2 of the SECs also provide a backup source for elevator trimmable horizontal stabilizer or THS control. There are 2 flight augmentation computers, FACs, that provide rudder control. This diagram shows the hydraulic power sources that drive each flight control. Let's continue with the introduction. The forward or aft movement of the side stick commands a pitch rate signal to 1 ELAC. For a given airspeed, the signal moves the elevators to a position that corresponds to the pitch rate commanded by the amount of side stick deflection. As airspeed varies, control effectiveness varies directly, so control surface deflection requirement varies indirectly. Once the pitch attitude is attained and the side stick is released to neutral, the pitch attitude will be maintained, and the THS will automatically trim to maintain 1G flight. ELAC 2 normally controls pitch. Similarly, the lateral movement of the side stick commands a roll rate signal to the other ELAC. For a given airspeed, the signal moves the ailerons to a position that corresponds to the roll rate commanded by the amount of side stick deflection. If control effectiveness is low and/or rate command is high, the ELAC will send a signal to the SECs to augment the roll rate commanded. Again, as airspeed varies, control effectiveness varies directly, so control surface deflection and augmentation requirement varies indirectly. Once the angle of bank is attained and the side stick is released to neutral, the angle of bank will be maintained. ELAC 1 normally controls roll. The FAC or the rudder pedals control yaw inputs. The FAC automatically controls yaw damping and turn coordination, so no manual rudder input is normally required by the pilot. Rudder trim is available through the FAC by use of the rudder trim switch on the pedestal. The FAC also provides rudder limit, characteristic speeds, and reactive wind shear guidance. FAC 1 normally controls yaw inputs. Let's review what we have learned about control inputs. A lateral input to a side stick is a command for a roll rate to achieve an angle of bank. A forward or aft input to a side stick is a command for a pitch rate to achieve a pitch angle. Once the angle is set, a load factor of 1G is maintained. Once the selected rate is achieved, you can release the side stick to neutral to maintain an angle of bank or pitch attitude of 1G. A change of airspeed will not require a pilot to adjust for the amount of side stick deflection or to retrim the aircraft. Yaw input requirements are automatic during normal operation. Pitch and roll inputs are limited by the ELACs to prevent excessive maneuvers to prevent flight operation outside the flight envelope. The input signals from the side sticks to the ELACs and SECs will properly deflect the flight control surfaces according to the input only within the regime of normal law. The pitch control surfaces are 2 elevators and a trimmable horizontal stabilizer, THS, controlled by ELAC 2. The THS is automatically positioned by ELAC 2 to allow the elevators to return to neutral after a change in pitch attitude. But the THS can also be manually trimmed using the pitch trim wheel when ELAC 2 is not controlling pitch trim. On ground, except after landing reset, and during computer or hydraulic failures. The roll control surfaces are one aileron on each wing controlled by ELAC 1. The ailerons provide primary roll control of the aircraft and are augmented by the roll spoilers that are commanded by ELAC 1 to the SECs when the roll command requires a higher roll rate. There is no manual aileron trim. This function is controlled by ELAC 1 by positioning the ailerons directly instead of using a trim tab. The yaw control surface is a single rudder controlled by FAC1 or by manual control through the rudder pedals. The FAC automatically controls yaw damping and turn coordination, so no manual rudder input is required by the pilot. Rudder trim is available through FAC1 by use of a switch on the center pedestal. There are 5 spoiler panels on each wing. They are controlled by SECs 1, 2, and 3. The 4 outboard panels 2, 3, 4, and 5 are the turn spoilers and augment roll rate commands. During flight, the 3 center panels 2, 3, and 4 can be deployed as speed brakes by pushing the speed brake handle down and pulling it aft. The ground spoilers are armed when the speed brake handle is lifted when the handle is in the set position. On the ground, all 5 panels 1, 2, 3, 4, and 5 deployed to act as ground spoilers. The handle does not move during ground spoiler actuation. There are 5 slat surfaces on the leading edge of the wing and 2 flap sections on the trailing edge. The slat flap control computers, SFCCs, provide the electrical signals to electrically controlled hydraulic actuators that position the surfaces. Each SFCC has 2 channels, one for the slats and one for the flaps. Each channel can drive its associated surfaces. The flap lever, located on the right side of the pedestal, operates the slats and flaps. The flap lever has the following positions: 0, 1, 2, 3, and full. The flap and slat position is displayed on the EWD and is indicated by white dots. Here the surfaces are extended to position 1 plus F. Click the labeled positions of the flap lever and watch the display on the EWD. The ELACs and SECs send signals through 2 Flight Control Data Concentrator computers, FCDC, to the EIS, but the FACs send signals directly to the EIS. The position of all primary flight controls are displayed on the ECAM flight control page. The status of ELACs and SECs are displayed on the ECAM flight control page, but the status of the FAC is not displayed. This page is displayed automatically when the flight control check is performed before takeoff. We'll describe each display now. Adjacent to the flight control symbols on this page is the symbol for each hydraulic system that powers the specific flight control. The symbols are G, B, and Y. The symbol for each hydraulic system normally is displayed in green, but is displayed in amber if the associated system pressure is low. Next are the spoiler and speed brake indications. All panels are shown here retracted. When a panel is deflected by more than 2.5 degrees, the symbol appears as an arrow. Click the buttons on this page to view the available spoiler operations. A faulty spoiler panel that is in a deflected position when it should be retracted displays amber. A faulty spoiler panel that is retracted when it should be deflected displays with its position numeral in amber. The condition of the ELACs and SECs is normally displayed in green with a gray box. Failures or turned off computers display in amber. More on this later. The green symbols for each flight control move over a fixed white scale during surface deflection, and the pitch trim position is digitally displayed. We'll describe these symbols in more detail with the associated flight control. This is the rudder trim control. The selected rudder trim is displayed by a small blue line below the scale. Both the rudder and pedal deflection is limited as a function of speed by a rudder travel limiter. The rudder travel limit is indicated by small white marks in the high-speed condition. Finally, there are two panels located on the overhead panel to control the flight control computers. The switches on this panel are normally in the on position. This completes the introduction to the flight controls. Now let's answer some questions.